All right, we are now live.
Research San Diego.
Well, we're live from San Diego, Idaho. We're on question 3. Research.
To go, no go stimulus? Do you know what that is? To go, no go?
I don't know. I don't know what that is.
Well, it's a large enough sample, so it's not the first one.
Well, it's only it's 20 females and 15 males. So is the males large enough?
Well, is it 35 people?
It says the QQ plots of both random samples and see that they are approximately normal. So would it be number 3?
Oh, for both random samples. So are they both small?
Yeah.
So is it the second one that no, the company needs to check that all the data combined is normal?
Well,
I think it's the second one.
But they say that it's
Mason's got a point that it says they're both random samples.
And they see that they're approximately normal.
All right, let's just try number
3.
I'm gonna put number 3. Yeah.
All right, sounds good with me. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? So we know that sigma is unknown.
Right. I think it might be the
samples.
I think it might be the third one. Oh wait, no. No, maybe the third one.
So it's not 2, it's not 4, and it's not 1.
Because they're
The 4 types of confidence intervals. Which ones are appropriate?
What's the difference with mean?
The I think the U is the mean, and the sigma is the standard deviation.
Right, but for the second one, it says the confidence interval for the difference of means.
What does that mean?
I think 2 or 3. I feel like both of them.
3. Let's just try 3.
Cool.
All right. Are researchers interested in estimating?
Did you just do the second one?
Well, if we increased n,
we increase n, I think the numbers would get smaller.
the confidence interval would get smaller, which would, I think that would decrease. It decreases the z or the t score, but how does that relate to the p score?
All right, so it's not the first one. What are we trying to do? Which of the following would produce a confidence interval with a smaller margin of error?
Oh yeah, if we increase, I think if we increase it to.
Bless you, Christy.
So I think if the second one, right?
That's what I said.
Let's just, because it'd be like 2 times the standard deviation. So let's just say that's 4. and then over the square root of not. Let's just pick a random number. So 3. So that's 8. 3. That's 3. That's 3. And if we increase this to 6.
No, if we increase the confidence interval, the confidence, that percentage, then the number gets bigger. But if we increase n, or the sample size, then the confidence interval gets smaller.
So it'd be the last one.
Yeah.
Yeah.
That makes sense.
You guys working on 6?
Yeah. So is this one we just put into the quantitative one? Because if we try to do it by hand, we'll get a wrong answer.
I don't know. Maybe.
I think so.
N equals 4. The mean equals 1,000. Standard deviation equals 2.
I don't know how to do this one.
Oh, did you get the margin? Did you get 3.182?
Yeah. Just got it.
Did you use the quantitative thing, or did you actually?
I did the quantitative thing.
Okay, 996.818.
I think, I don't know, like whenever we try to do it, I think I could try it real quick and see what I get.
I just feel like we always get the wrong answer, and then we use the quantitative. It works. So all we did, Mason, was we used the quantitative inference procedures, and then we plugged in what we knew.
Oh, I think I pulled up the wrong spreadsheet. That's why.
I'll be real. I had no idea how to pull up the QQ plot yesterday, but like after like everyone was explained it, I was like, I'm not asking a third time.
Oh, really? It's just one of the settings inside the quantitative. Like in the quantitative inference one, it's on the bottom, but there's another one called the quantitative descriptive. It's a whole separate file, and it's got a tab for just QQ plots.
Oh, gotcha. Let me finish this.
Yeah, I don't know. I forgot how to do the calculations now because we've used the quantitative inference thing so many times.
All right. To assess accuracy of the lab scale, standard weight is known to be 1 gram repeatedly weighed Close the square root. How large?
So I just did it real quick. What did you guys get for the last one? Sorry.
So the lower bound we got 996.818.
Okay. And then the upper was 1,003.
Yeah.
Okay, cool.
Number 9. I think we need to use an equation.
What is the margin of error on the spreadsheet?
Add the confidence. Do the upper minus the lower divided by 2.
Okay.
Are you guys on? Have you guys figured out how to do 9?
I'm working on it right now.
This is that second part of the lesson.
All right, I got it, but I don't know if it's right.
What did you get?
pull up
196.
the equation? Did you pull up the equation, Aaron, for it?
I got 196, but then I squared it because n is the square root of n.
Oh, you're supposed to square that number?
So
Or take the
because
square.
I set it up 1.96 times 0.01 divided by the square root of n equals 0.001. So then I multiplied the square root of n over, divided the 0.001, did that, and got 196 equals the square root of n. So then I squared both sides and got a huge number. How did you get 196?
I have written on my paper. It's not. I don't know why. But it's just the z-score times the standard deviation divided by n equals n. But I think I can't tell if I wrote a 2 like it's squared or if it's just a weird thing. We'll just test it.
Z-score times what?
Or not the z-score, but the 1.96 times the standard deviation divided by n.
Oh, margin of error, m equals the z-score times sigma over the square root of n.
In this one, it's given though. The margin of error is 0.001. 0.0001.
Right, but so you do 0.001 equals the z-score times sigma over the square root of n. The square root of n's still there.
Okay.
What'd you use for your z-score? 1.96?
Yeah.
Obviously.
We got the same answer.
3, 8, 4, 6. All right, so you're putting 38,416?
Yeah.
The next one is the last one. They think the apartments are smaller than what they claim. So the null is that they're all 1250, and they think that it's less than 1250.
Maybe I should be keeping better track of how we got each answer. It don't matter. In a statistical test hypothesis, we say we reject the null hypothesis. Ooh, I have this written down. Learned this yesterday. We reject
A or B?
when P is less than alpha.
Okay. I don't think so because it says they're. Well, actually, if they're not equal, it doesn't work, does it?
Wait, which one are you guys on?
12.
This should work.
I think 12 might be the second one, just because the sample sizes aren't big enough. Oh wait, no, it says that they're normal.
I don't. Well, yeah, I guess the variances could still be equal because if one's like 4 times bigger than the other, then it won't work. But it doesn't say they're equal.
Yeah, it might be the third one then.
Yeah.
Okay, moving on.
Oh man, which one is stupid errors?
There's too many words in this one.
I'm gonna go look back in the
So,
book.
type 1 error is committed when we reject a null hypothesis. In reality, true. Type 2 is committed when we fail to reject. So type 1 is reject the null hypothesis.
She rejects it. So.
So type 1.
What lesson are you looking at?
I'm looking at the notes for lesson 9 recap. So are you in the lesson summaries?
No, I'm looking. I went to lesson 9 now.
What is type 2, Aaron?
Type 2 is when you fail to reject the null hypothesis. I'm gonna write that down.
Would it be the first one for 14?
That's what I think, yeah. All right, number 14. If the level of significance A is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
Hmm.
Oh, I was talking about this one. I thought this one was A, or the first one.
I think it's still true. So I think if one gets smaller, the other one has to get bigger, right?
Yeah. It makes sense because there's a larger possibility of it having a type 2 error.
Doesn't that kind of seem weird though?
What?
Because you don't want either of those, but if you're like, oh, I really don't want to have a type 1 error, then you're probably going to have a type 2 error. And if you don't, you're like, oh, I want to make sure I don't have a type 2, then you're probably, I don't know.
Maybe. I almost think there's no relationship, but I don't have lesson 9 pulled up.
Oops.
So it says in the review, the value of A is the probability of committing a type 1 error.
I'm okay with A for now.
All right, that sounds good.
The nicotine.
So we have to come up with a p-value, right?
So do we do 1.53 minus 1.5 divided by
Um,
0.17 divided by 10?
Oh, maybe.
I got 1.76 for the Z, B or T, whichever one. Oh, I'm gonna put this in here. I don't even know what I'm doing.
All right, is it what is it, a 2-sample t-test? What are we doing here?
I think this is an old Z-score one. Normal probability applet.
Because it has a known standard deviation.
I think so.
It might be.
1.764. So do we do all the numbers bigger than that?
What's a 0.05 level of significance? Is that the 95% confidence interval?
No, that's saying the
Oh,
the
that's what.
alpha equals 0.05. And so I think this one is less. He is less. So we fail to reject.
Did you get a p-score of like 1.76?
I got 0.038.
How did you do that?
I put a Z-score in of 1.764.
Oh yeah, I forgot about that. We haven't done this in a while.
So fail to reject since it's lower than 0.05. Wait, is it lower than 0.05?
Yeah. It's 3% to 5%.
Okay.
So this one is dependent. Oh, maybe not. Because it said 100 for each group, I thought it was like, oh, it depends on. Let's look.
Is it either the second one or fourth one, right?
I think it might be the second one because it doesn't. What male student or what female student you pick doesn't student you pick.
Yeah, that's
It's not independent, and it's not ANOVA.
it's not paired. So I think it's independent sample t-test.
It's not that.
Why not?
It's not that?
Independent sample?
Yeah.
Two samples are independent if knowing which subjects are in group 1 tells you nothing about the subjects in group 2. So, boys and girls?
Well, I think because he was explaining this yesterday a little bit. Because they're not related at all, like, and when you're choosing.
I do agree that that's the only option. I just don't think I get why it's.
Because which boy you pick doesn't affect which girl you pick.
Yeah.
Gotcha. That makes more sense.
I feel like this test is going to be hard. This is a bunch of wordy stuff.
I know. I remember taking the pre-test for physics and the post-test.
Uh-huh.
Like, it was just word problems, and I was like, I don't even care. I'm just guessing. This is too much reading.
I did so much worse on the post test. Educators interested in academics.
Ooh, this is totally dependent.
This is the last one.
Yeah, I think so.
Okay.
Ugh. I was hoping we were actually going to use the Excel sheets that were up above.
We're over halfway through, right? That's good.
It's not opening.
My thighs are a little sore from squatting yesterday, Aaron.
Dude, my back is feeling it. I was just thinking about that.
From doing those pull-ups, dude, I was surprised how sore my back was this morning. I'm not like, my legs aren't bad, but my back really hurt.
I feel like I just need to squat like every other day and just call that good on squats or legs.
Do you guys think 18's the first one?
I can't even open this.
Really?
I downloaded it, but it won't open. Oh, there we go.
I hate having so many files open.
Dude, my computer is tripping out right now.
Measure the dissolve.
Okay. One of the questions, we have no idea what type this thing talking about.
I don't really get these ones.
Of the 4 types, okay. So milligrams per liter. So it's the density.
Yeah.
Does that even matter, Aaron?
I don't know. Well, I was trying to figure out what the heck that even meant. So we can know the mean, and then we can know sigma, right? No, we don't know.
I think it's the first one for 18.
Yeah, I like the first one.
And then I think I got some answers for 19, 20, and 21.
Oh, look at you, Mr. Do all the work.
You just plug them in.
You just plug them in, yeah.
Which tab did you use?
I used the
One sample.
one sample, yeah.
For the in the lower and upper, did you get 1.496 and 1.564?
The lower, sorry, maybe 11.168 and
Yeah.
15.217 for the upper.
I got that wrong. What am I doing wrong here?
So n is 20, mean is 13.193, and standard deviation is 4.326.
Yeah,
Like those.
yeah.
I
Well,
did.
obviously you did.
Does it not update automatically when you plug in all the numbers?
Did you put it in summary statistics or in variable one?
Oh, I put it in variable one.
It needs to go in variable one.
Yeah, I put it in variable one, but they didn't change. That's weird. Maybe I'm gonna get out of there and then.
Matt, you get 2.025,
Yeah.
and then 11.168, 15.217.
Yeah. I think 22 is the third option.
Random. What number do you think it
There you
was?
go.
Was it the dependent one?
I think 22 is the third option.
Third option, using independent samples. So you're saying where you live, it doesn't matter where you live?
What do you mean?
Well, so I was kind of thinking it's going to be dependent because it's Hummer sale prices in New York versus Hummer sale prices in New York versus Los Angeles. Like right off the bat, that kind of sounds dependent, like of where you live.
Well, I kind of thought it doesn't. You pick in Los Angeles doesn't affect which one you pick in New York.
You're right. I gotta quit thinking like that. It's one in group. Anyone in group one has nothing to do with the Hummers in group two.
Right.
Calculate 95%. This is a 2 sample.
Yeah.
Oh,
What are we comparing? The
price of Hummers in Los Angeles to price of Hummers in New
Okay.
York. Hummers cost more in LA.
I guess, yeah.
Lower.
did you guys get? That's not right.
I got is the confidence interval just the lower bound and the upper bound?
Yeah. What'd you get for?
Negative 423.
That's what I got, but it seems weird.
Yeah. So you got Matt?
What for? Yeah, negative 423.
So is that the lower bound?
What does that mean though? That on average, okay, so what they did is they did group 2 minus group 1 and they got a number. And if the number is positive, that means that New York was more expensive than LA. So basically this is saying most of the cars were more expensive in New York. That's not any of the answers, I'm just saying. Just trying to make sense of what. Just saying.
Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses bones.
So this one is is this the Innova one? Or no?
That sounds right. Because it's a group of no jumping, a group of low jumping, and a group of high jumping. So it's 3.
Yeah, that makes sense.
It's more than 2. No. Bought a wetsuit, Nathan.
What?
Bought a wetsuit.
Are you looking online?
No, actually, I did. Right when I said that, I realized you guys were selling one too. But it's a different kind of wetsuit.
Yeah, this is an old one that her parents gave us for some reason. I don't know why.
Yeah, I got a triathlon one. Actually, the test statistic. So that's just the F value, right?
Yeah, so 7.978.
7.978.
And then 0.002. Is that right?
02. Yeah.
And then, I guess just the conclusion of this test. So it is less than 0.05. So what does that mean, Aaron?
P is less than A. So the deficient.
I don't know why it's so hard to understand that.
Well, I just learned yesterday from that dude.
Well, I just can't remember. I feel like they should be like, it failed, or it rejected or didn't reject, not it fails to reject or rejected.
So there is sufficient evidence to conclude that the mean bone density between all groups are different.
Oh, I guess this is a little different than that, huh?
No, I think it's the fourth one. To suggest at least one of the groups is
That's
different.
the one I was looking for. Save all responses. How many more we got left? We got 4 questions. Then I can go to the gym.
Are you playing tonight?
Huh? You say, am I going tonight?
Yeah, are you playing?
You say, am I going tonight?
Are you going? Are you playing?
I'll go. I don't know how much playing I'll do because we'll have you, Greg.
Say that every time, dude. And then you're always out there playing.
But my toe kind of hurts too. That's the other reason. But Greg's there, which is the main reason. So this one's gonna be dependent, right?
Are you sure, Aaron?
I think so. I could be wrong though.
Oh yeah, it is because
I thought
it has to be the same airline and like same flight, right?
Oh, same day. It's the same day. Not necessary.
No, it's
So it's not the
these
same
6 days
plane.
apart.
No, so it's like it could be like July 9th is when the flight is leaving, and that's 14 days, and that's 90 days.
So would you say dependent samples test?
Yeah.
Direct flight costs.
This is a paired sample, right?
Yeah.
Yeah, I think so.
Which one goes where? Did it say? 14 days minus 90 days.
The 14 goes in the first one.
Yeah.
There's a gap in there. It's kind of weird.
Yeah, I did it on one of the other ones too.
It doesn't. It just excludes those ones, which is good. I think that's what it's supposed to do.
Okay.
Test 4.19.
Test statistic. Where is that on here?
The key.
I got negative 0.142.
For the T-score,
Yeah.
What'd you get, Matt?
1.685.
All right.
Wait, what'd you get, Aaron?
Wait a minute. What's going on here? It didn't do all my differences.
$38.1. Mine are right. There's just the one where there isn't for variable 2. There isn't a price for number.
So for Dan would get 1.685.
What?
Did anyone get 1.685?
I think that's what Matt got.
Yeah. So I'm looking back at the problem though. The very last sentence, it says do 14 days. That might be a minus sign. 14 minus 90. So if it's 14 minus 90, then the 14 day needs to be in the second column. I think.
It's A minus B. So 14 needs to go in the first one.
Dang it. I had it there. Now I have to go back and get it.
Oh, we're done. Oh,
Dang it.
So what did you have as your confidence interval for the
confidence interval.
yeah?
Negative 4.431 and 53.654.
No, I'm sorry. The confidence level.
95.
Is that what it's supposed to be?
It wouldn't change the T-score.
Oh, it doesn't change those?
It would change the confidence interval. Oh.
Oh, interesting. I feel like on the other one it changed the P score, but
All right, I give up. We can switch those two. Did you guys get them already?
Yeah.
What was the test statistic and everything?
1.685.
Oh. And then the p-value?
0.096.
0.96?
0.096.
Okay. You can probably stop the recording now.
okay.